All right, good afternoon, everyone. Welcome into the Morrison Planetarium. We are here in Golden Gate Park on the unceded homeland of the Ramaytush Ohlone, who are the original peoples of the San Francisco Peninsula. My name is Guadalupe, and I will be your host for the showing of Tour of the Universe. But before we embark on this journey, we do have a few house rules for everyone. First of all, food and drink is not allowed in the planetarium, so if you manage to sneak any snacks in here, please sneak them right back out. We want to keep the theater nice and clean for everyone. If you have any electronic devices such as cell phones, cameras, iPads, please make sure that they are silenced and put away and do not come out for the entirety of the show, as lights and sounds are especially distracting in this especially dark environment. Our planetarium is lined with 6 projectors at the base of the dome. If you happen to stand up during the show, you will be casting a giant human-shaped hole in our universe, which is not scientifically accurate. So for the sake of accuracy, please keep your seats for the entirety of the show. But if you do need to leave for whatever reason, exits will actually be located at the top of the stairs, not at the bottom where you came in. And lastly, this planetarium can create a very immersive experience, but I promise you, you are not actually flying through space. If at any point you experience any kind of motion sensitivity, you can just close your eyes for a few seconds and the feeling should pass. All right, now I still see a couple bright cell phones in the audience, so we'll wait for those to be put away before we get started. All right, thank you so much, everyone. So now you can feel free to sit back, relax, and enjoy your tour of the universe. So here we are at the starting point of our tour, right where we currently sit. We are looking down at Golden Gate Park from about 3 kilometers above the Earth. And we can see the De Young Museum across the street from us here in the center of the screen. Below it, the Academy of Sciences. And we are specifically right here in the right side of the Academy. Some of you probably found parking wire up here, down here. Probably wasn't too bad today. Well, for many of us here at the Academy, San Francisco is home, and home is an excellent place to start. But let's zoom out a bit now to take a look at our entire home planet. And as we begin our ascent, a few words about the software I will be using. It is called OpenSpace, and it is a collaboration between NASA, Linköping University in Sweden, and the American Museum of Natural History in New York, and it is completely free for anyone to download if you'd like to check it out yourself. But just know that it is still in its beta phases, so if you notice a few bugs and glitches here and there, just know that that's the software, that's not my fault. And as we zoom out a bit further, we can see the rest of the San Francisco Bay Area, the iconic Golden Gate Bridge up here, my hometown of Oakland, California here. Go A's for now. And as we zoom out a bit further, we can see the rest of California and North America to the right, and the Pacific Ocean to the left. And finally, right around here, we are at about 10,000 kilometers above the Earth, and we can see our home planet in all its glory. And one other thing we should be able to see from up here is a faint orange line going around the Earth. We could see it coming into view right here now. And this actually represents the orbit of the International Space Station. It orbits only 225 miles above the Earth, and it circles our planet once every 90 minutes, traveling at over 17,000 miles per hour. It is the largest object we have ever built in orbit, extending over an area about the size of an American football field. The ISS is currently, and for the near future, humanity's only presence beyond the Earth, and as far as humans travel into space these days. Well, as beautiful as our home planet is, it's time for us to move on to the next stop on our tour, Earth's nearest natural neighbor in space. Any guesses as to what that is? Yeah, I think I heard a couple people whisper it. We're going to head over to take a look at the moon. Let's move the Earth out of the way a little bit first so we don't crash into it. Between 1969 and 1972, NASA's 6 Apollo missions brought a total of 12 incredibly lucky guys to walk on the moon, the only brief presence of humans on another body in our solar system. At 240,000 miles from the Earth, the moon is on the furthest edge of the human scale. Some of you may even own a car with that many miles on it. You could even imagine driving to the moon if you drove for 4 months nonstop at top speed. Although I cannot recommend it, the roads are poorly maintained. There are 2 distinct areas that we see on the surface of the moon, these light-colored mountainous areas, and then these darker patches called mare. The mountainous parts are what we call crater saturated, which means that you literally cannot create any more craters there. If a meteor were to crash on the surface of the moon, which they still do from time to time, the impact would create a crater, but it would also destroy craters that are already there. Now, the dark areas were created a long time ago when something very large and very heavy hit the surface of the moon and cracked open the crust. Hot lava poured out from the moon's interior to fill these impact zones, and when they cooled, they created the dark, smooth lunar mare that we still see today. The word mare means seas in Latin, because when astronomers of old looked up at the moon and saw these dark patches, they imagined that perhaps they were bodies of water. But they were wrong. What they actually are smooth, dark basaltic plains, the leftovers from impacts from long ago. Now, as we move on to visit the rest of the universe, we're going to need a more useful measuring stick, since at these scales, using miles is kind of like using inches to describe the distances between cities. Doesn't make a whole lot of sense. Astronomers instead use the more convenient measurement of light speed. Light travels at the mind-boggling speed of 187,000 miles per second. Remember that number, it's going to be on the test later. 187,000 miles per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any humans have done so or since, it takes light only 1.5 seconds to cross that distance at the speed of light. That's the time it takes for a short pause in conversation. But now we take another leap out into the much greater realm of our solar system, watching the moon and the Earth in its orbit as they recede. On our journey, we'll be traveling much faster than the speed of light, at the speed of the human imagination, with the help of computer models showing us the most accurate images and information available. So now the nearest star to the Earth, the Sun, comes into view. The Sun is 93 million miles, or 8.5 light minutes away, about the time it takes for a short coffee break. And we're zooming out from our solar system and viewing the orbits of our neighboring planets in order from the Sun. Can everyone help me name the first few planets? What's the closest planet to the Sun? Mercury, the second. Venus, the third. You should know this one. The Earth, and the fourth. Mars, excellent. You guys don't need me at all. These are our 4 rocky terrestrial planets. And as we zoom out a little further, we see our 2 Jovian planets, our gas giants, Jupiter and Saturn. And out further still, our 2 ice giants, Uranus and Neptune. And that's it. That's everyone, right? Is anyone missing? Well, last and among the least, we have Pluto in its eccentric tilted orbit. Now, those of you with good memories might remember that prior to 2006, Pluto was actually considered one of the planets. And you might be wondering what Pluto did to get kicked out of the club. Well, in the years following Pluto's discovery in 1930, almost 100 years ago now, astronomers have learned a lot more about what kind of objects exist in this outer region of the solar system known as the Kuiper Belt. It turns out that there's a lot out there. Are we ready to see what the Kuiper Belt looks like? Yeah, it's a lot of stuff. Thousands of other objects, some even very similar in size to Pluto, have been found out here. So either we need to call all these other guys planets and memorize all their names in elementary school, or we need to take a step back, re examine our understanding of what a planet is, and change the definition. And that's exactly what astronomers did in 2006, and Pluto didn't quite make the cut and was reclassified as a dwarf planet. It was very clear that it fit into the category of all these other objects much better than into that of a planet. But keep in mind that this is just a change in classification, and it does not make Pluto any less of a beautiful and fascinating world. And now, as we speed away from our local neighborhood in space, we'll add in the paths of the earlier spacecraft sent out during the 1970s to explore the solar system. Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, which are the farthest traveling human-made objects, all traveling fast enough to escape the sun's gravity and leave the solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not yet traveled as far as light travels in a single day. We have now left our solar system and planetary scales far behind, and we are now in interstellar space, the space between the stars. Distances now become so immense, it will take us over 4 years at the speed of light just to reach the next nearest star, the Alpha Centauri system. That's the time it takes from freshman year to graduation for a college education, if you're lucky. And as we move even further and further beyond even our most far-flung probes, we'll stop for a moment to consider whether humanity has made its presence known beyond the solar system. We are now inside the radiosphere. It represents the current limits of the most distant radio signals that humanity has broadcast, or rather leaked out into space, and it extends about 90 light years in all directions out from the Earth. Beginning in the 1930s, strong radio waves, early television and radar signals, and later the detonation of atomic weapons emitted electromagnetic radiations strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they travel at the speed of light. So this is humanity's electromagnetic footprint on the universe. Of course, the radiosphere is expanding at a rate of 1 light year per year, so this begs the question, is anybody out there listening? Let's think about that for a moment. These markers indicate some of the many thousands of stars that astronomers have discovered over the last 30 years or so, which have one or more planets orbiting them. We call these exoplanets, and we are looking for any of them that are Earth-like with conditions suitable for life as we know it. Our technology is not yet able to answer that question, but new generations of astronomical instruments are devoted to that search. But the important point here is that quite a few of these planetary systems are within the 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anyone out there able to listen and to answer back, the communication delay between hellos could be decades in time. And of course, planetary systems beyond the radiosphere, more than 90 light years away, haven't heard from us yet, but eventually will, as the radiosphere is always growing. As we pull back further, we will begin to see the Milky Way and its structure. I find this to be the most humbling moment of our show as we see mankind's influence on the universe. As huge as our radiosphere is, our radio imprint on the universe is tiny in comparison to the size of our galaxy. Now leaving the Milky Way and looking back at our spiral galaxy, we see that it is about 130,000 light years in diameter, a distance in time and space equal to the length of the history of the human species. The Milky Way is so huge, we estimate that there are at least 300 billion stars in the galaxy. If our recent discovery of so many exoplanets, just within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, let's take note of the shape of our galaxy. It has a lovely spiral shape with a bright center and spiraling arms coming off of it. The Earth lives in one of the arms. And when we look at it from an edge-on perspective, we can see that it is a very flat disk. It nearly disappears when we look at it from edge-on. The Milky Way is only one of many hundreds of billions of galaxies that comprise the known universe. In this giant leap, we now see a view where each point of light represents not a star, but rather the location of an individual galaxy, each containing hundreds of billions, perhaps even trillions of stars. We live in the local group, which contains about 30 galaxies, large and small, including the next nearest large spiral, the Andromeda Galaxy, only 2 million light years away, so pretty much just next door. And it's also headed right for us. We're going to get to know it pretty intimately in about 5 billion years. Now, as our picture expands, we discover that galaxies are not distributed evenly throughout space, but clumped together in clusters with great regions or voids that have very few galaxies. This picture represents the 30,000 closest galaxies to us in a space over 300 million light years across. The astronomer Brent Tully compiled this representation from the work of dozens of astronomers working over decades of time and color-coding the densest regions of galaxy clusters in red. And now from here, we can go out further to see the data from automated systems that are mapping even more distant galaxies. Even here, in this view of the large-scale structure of the universe, we continue to see clusterings of galaxies in groups and strands with immense empty regions where little can be observed. And by the way, the universe is not shaped like a bow tie. Remember when I asked you to take note of the shape of our galaxy? The dark areas result from our view from inside the galaxy, all the stars, dust, and gas nearby within our flat spiral, which obscure our view of the universe beyond. But as the surveys scan more and more of space, the dark gaps will eventually be filled in. Earlier, we talked about the speed of light. Does anyone remember that number? I think I heard someone whisper it. It's 187,000 miles per second, the speed limit of the universe. However, the distances we've traveled are so immense that it takes eons, even at the speed of light, to traverse them, which means even our fastest spacecraft would take lifetimes to travel even just a fraction of the length of our own galaxy, let alone all the way out here to the edges of the known universe. But there is a benefit to this universal speed limit. Since light takes time to reach us, It means that the further away something is from us in space, the farther back we see it in time. So when we look out into the depths of space, we are seeing a younger version of the universe we live in. And we can use this to learn about how the universe has aged, how it's changed over time. To see an example of this, as we move still further out, we will begin to see these bright red dots on the outside of our little universe butterfly here. There they are, coming into view now. And what we see here are not stars, not galaxies, but the brilliant cores, the very central nuclei of very young, very distant galaxies. These are the quasars, which is short for quasi-stellar radio sources. And these blazing objects are all billions of light years away, so now we are looking so far back into the depths of time and space that the most distant quasars represent the universe at a much earlier age, near to the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe's yearbook photo. And before there was a teenager, there was a baby. We are now looking even further back, beyond the quasars, to a time before planets, stars, and even galaxies began to form. This is the cosmic microwave background. All evidence indicates the universe we live in is about 13.8 billion years old. From data compiled by Planck and other spacecraft, this is a picture of the infant universe, a mere 380,000 years after the Big Bang, where space and time began. And it's not a typical photo, but a temperature density image. The light echo of the Big Bang, color-coded with light areas corresponding to the hottest, least dense regions, and dark areas the coolest, densest. Now, these fluctuations in temperature and density are actually extremely tiny, varying by no more than 1 part per 100,000. But eventually they gave rise to the large-scale structure of the universe, the clumping and clustering of galaxies everywhere. And though our view here is of the outer edge of the known universe, the earliest light possibly visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. So now that we've traveled as far back as the laws of physics will allow, there's really only one direction left for us to go, and that is back home. So now I ask that you prepare yourself, for this could possibly be the worst free-falling dream ever. We are diving back in towards our planet, crossing an expanse of over 13 billion light years. We've presented you with this view of our universe and the latest in cosmological and astronomical information, covering eons and observing objects billions of light years apart. We live in a golden age of astronomy. New generations of telescopes and spacecraft are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. Whew. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauty and wonder of our universe. All you need is a night sky, and if you can, get away from the lights of the cities and look up. Even a good pair of binoculars makes for a decent first telescope. Astronomy clubs around the world invite people to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Astronomy as a hobby can offer an endless supply of satisfaction. I do hope that you will join us, who dream among the stars. And as we arrive back at our home planet and at the end of our show, I want to thank everyone for joining us here today at the Morrison Planetarium. Please remain seated until the lights come back up, and before you leave, make sure to check your surroundings for personal items so that nothing and no one is left behind. Exits will be at the top of the stairs, but if the stairs pose a challenge for you, please just remain seated and one of my colleagues can assist you to a lower exit. If you have any questions or comments, feel free to stop by the pilot's booth up top to talk. Once again, my name is Guadalupe. Thank you and enjoy the rest of your visit at the California Academy of Sciences.